this one will be as a next video to continue with the last part of this section. As I told you before, and I showed you the histogram, the box plot, which consists of first quartile, second quartile here, which is the median, and the third quartile is this one here. And I showed you as well, when you have the first quartile and the third quartile, you can calculate the IQR, and then you calculate the upper whisker and the lower whiskers. Basically, those are, we call them 5 numbers sometimes, some of the statistics. They call them upper or 5 numbers summary. So sometimes they take the minimum and maximum. So you can always calculate the minimum, the maximum, the first, the second, and the third. And those are a couple of things you might really use in order to analyze your data. So they are very important, but the most important is really to draw them like this one. Another useful use of data of box plot, if you have multiple box plot, imagine this is for each month, you have kind of box plot for each month in terms of stock price, something like that. So you can see the higher the box is, it means it was the volume of trade in billions was higher. So you can see here, I think the month number 1 and month number 6, it looks like the boxes are hitting higher volume, but don't be tricked here. Look at the second quartile, which could be the middle of each box here. You see a horizontal line inside each box. That means it's a median. So you can see the highest median. If I may really make a line here, let me see if I can insert a line to see a little bit better here. Illustration, let's take a shape and let us take a line here. So okay, let me make a horizontal line, something like that. Okay, and let us move it. And you can see here, if I put it around the median here, you can see the highest median is probably 11 here, and also the January. So January and November, they have more or less higher median. But if we look at the quartile, the third quartile is higher when it comes to month June. But look at the size of each box plot. You can see in December, the box plot was very wide, and it means there were very high variation in terms of trading during this month. Maybe because it's a Christmas time in here, it's called the New York stock market. So probably in New York, in Wall Street as well, they might really have a lot of activities during this month. But you can see another month, March, it's almost dead month. The box is the smallest box, and even it's higher. So it looks like most of the people during March, there is no high trade, or there is no trading activities during this month. So you can see there are really interesting way to represent data like that. You can see also some stars here and some circles. They basically are outliers. What does it mean? It means in month 6, one of the days, this could be one of the days, I don't know which day, but it was one day the volume was extremely high. But in July, there was also one day which could probably extremely low, as well as for November. This was extremely clear. But in the March month here, we have also one it's high. So you can read a lot of information, to be honest, with using box plot. It's a fantastic way to, and frankly speaking, this is one of the most used representation of data when it comes to data analysis. Another important thing is called Z-score. Z-score is basically, if you want to compare data from different sectors, or from the same sector but in different season, or the same season but in different locations, and you want to make this comparison, but you know that data could be different in terms of scale because of changing some conditions in these locations. So the best way is to standardize the data, and the best way to standardize data is to use what we call it z-score. It's a very simple calculation here, is to take the value of your data and to see how far this value from the average, and you want to know how many standard deviation this value. So basically, if I try to draw something here to show it visually to you here, imagine that this is actually the average here, point here, and you have a point here. Let us say you have a point here, and you have another point somewhere here. And now you want to calculate the difference, right? This is the y minus, so it's a negative because it's less, but in this case the difference will be positive. So z-score here will be negative, and this one will be positive. So let me erase this. Here it will be negative. Okay, so but imagine that after you calculate this, you calculate the S, and the S, the standard deviation, you calculate it in a way, and the size, it looks like this one. Imagine that this is a size, okay? So, or maybe I insert a little bit shape. It could be easier to represent what I wanted to show you. So let me show what I mean here. Imagine this is the size of the standard deviation, right? So let me make it a little bit thicker to make it visible here for you. Okay, okay, so it doesn't matter how it. Okay, and now we want to know how many standard deviation. This is the S. So how many? 1, 2, and maybe something. So, and this will be the z-score. The z-score is how many standard deviation you are far from the average. So if it's a -2, z will be -2. It means -2, it means how many standard deviation in here? 1, 2, 3.5, right? So that means the z-score here will be 3.5, something like that. So basically here will be negative, will be the z-score here will be negative. Yeah, I don't know why it didn't come with me here. Let me take it again. Yeah, here will be z-score will be negative 2 comma something maybe, and here z-score will be plus 3.5. Okay, so this is how you calculate the z-score. What does it mean, or how it will be interesting? It tells us something here. First, we can compare different data against each other using z-score, because we get rid of every units. For instance, if this unit is in dollar, the S also be in dollar, then the Z will be unitless. If this is a kilogram, the difference is kilogram divided by standard deviation, which is kilogram as well. It's also Z doesn't really carry any units. So this is one of the advantage, that you can compare apple to orange, but you need to standardize first. Or you can compare different places against each other, but you need to standardize first. That's one advantage. The second advantage is you might really put criteria by saying any value greater than or outside plus or minus 3 standard deviation, we consider them outliers. So this is again another way to capture the outliers. Okay, so I hope you understand this score. So this kind of data, they are not really data, cross-sectional data like the data previously we talked about it. In fact, this is a time series data where always it looks like two-dimensional here, but always the horizontal line represent time, always, right? But maybe we don't have time in our data, then we don't need to go for time series. So time series is very important. Another way could happen for us, and it really makes a lot of problems when analyze data. Imagine that you get big, large data set, and you wanted to see how this data looks like, you find out that the data histogram looks like this. It looks like very condensed. Most of the data are stuck in one location, and still you have other data set being distributed even far of them. Even if you look at the box plot became very tiny here, very compressed and compact, and most of the outliers are there. So in this case, it's really very tough to analyze this data. Usually, if you have data like that and you cannot read it like this, we need really to find a way to transform it in order to see better. It's like really touch screen. You want really to magnify this area by zooming in, and the only way to zoom in is to use some kind of transformation. And all touch screen using transformation in order to, when you zoom in, zoom out using your fingers to make it bigger or smaller, you basically apply transformation using the processor of your device. What would happen if we transform our data? In fact, this data we're going to use a logarithmic way. This is how you transform your data. It's basically you take the number and take the logarithmic of this number. And if you remember some math from high school, you know the logarithm, it always takes the high numbers and it turns them into smaller values. And this is what happens. So the transformed data actually distribution will look like this instead of the previous one here. And look at the histogram, and the box plot became decent, and this is how you zoom in your data for this kind of data here. So you can see this is very unusual situation, and if you want to zoom in to see better, the best way is to transform it, and you can see this picture. So guys, I finished the theoretical part of this session. The next video will be taking you to one of the data set. This data set is this one. I'm going to do some of the actions in order to show you most of what we discussed so far. See you in the next video.